Hello and welcome to Chapter 7, Section 9. Today we're going to look at the special products of binomials when we are multiplying special binomials together. So first I'm going to ask you to try and picture algebra in real life. We're going to imagine a square with the sides length a plus b. So let's say a is this long and b is this long. So the side is going to be a plus b. And this is a square, so this side is also a plus b. Now when we want to find the area is going to be length times width. So we're going to multiply a plus b times a plus b in order to get our area. And I want you to be able to picture what this means. If we do FOIL, we have a squared plus ab plus ab plus b squared. And we're going to combine these two. That gives us a squared plus 2ab plus b squared. What I want you to do is be able to understand what that means in real world. If we say that this is how big A is all the way down, and this is how big A is all the way across, then just this little square here, this is an A by A square, and its area is A squared. This rectangle has one side that's B, and the other side that's A. So this rectangle's area is AB. This rectangle has one side that's B and one side that's A. So this is also AB. And this side of this little square in here is B. And this side is B. So the area of this is b squared. So when I say this, I actually mean this square plus these two rectangles plus this square. Now, it happens like this every single time when you're working with squares. When you're working with squares of something that's an addition problem, you're going to get the same pattern each time. You're going to take the first one and you're going to square it. You're going to take the second and third one multiplied together, knowing they're going to be the same because they're identical. And you know that you're going to have two of them. And you're going to take the second thing and you're going to square that. So when you see this with an addition binomial, you know the shortcut. This is called a perfect square trinomial. A trinomial that you get by squaring a binomial. And you can get to recognize these easily. Here we've got x plus 4 squared. We know that that's x plus 4 times x plus 4, and we're going to get x squared plus 4x plus 4x plus 16. Which is going to give us x squared plus 8x plus 16. So we need to be able to find a quick way to do this. You're going to take the first one and square it. You're going to take the last one and square it. And you're going to take these two and multiply them together and multiply it by 2 because there's 2 of them. So let's see if we can do this one the quick way. We're going to take 3x and square it, 9x squared. We're going to take 2y and square it, 4y squared, and we're going to take these two, multiply it together, which is 6xy, and we're going to multiply that by 2 because there's going to be 2 of them. And that's going to give us 12xy. You good? Let's try some more. 4 plus s squared. 4 squared is 16. S squared is s to the 4th, and it's a positive number. And 4s squared doubled is 8s squared. Negative m times negative m is positive m squared. 3 squared is positive 9. And these two together is negative 3m times 2 is negative 6m. Try a couple of these by yourself. You've got checkpoint number 1 on page 522. Pause here, give it a shot. It'll go quickly. Come back when you're done. Check it out. Number 1, when we square x plus 6, we're going to end up with x squared plus 12x plus 36. 5a plus b squared is 25a squared plus 10ab plus b squared. 1c cubed is 1 plus 2c cubed plus c to the 6th. Please ask if you have any questions. The next trinomial we want to look at is a squared minus 2ab plus b squared. This is also a perfect square trinomial, but it's for a minus b squared. So, if we were to look at x minus 5, we know that's x minus 5 times x times x is x squared minus 5x plus 25. Negative 5 times negative 5 is positive 25, but these alone are both negative, and we combine them, we get a bigger negative. So it's the same idea as the ones we've just done, but our center number is just going to be negative. It's still going to be times 2. 10x plus 25. So let's do this one the shortcut way. 6a squared is 36a squared. Negative 1 times negative 1 is positive 1. And negative 6a times 2 is negative 12a. 4c squared is 16c squared. Negative 3d squared is 9 plus 9d squared, and multiplied together this is 12cd negative. So 2 of those are going to be negative 24cd. 3 squared is 9. Negative x squared is positive x to the 4th. And these two together, that's negative 3x squared times 2 is negative 6x squared. Okay? Try a couple of these on your own. This is, check it out, number 2 on the bottom of page 522. Pause here, come back when you're done. 2a, when you squared x minus 7, you end up with x squared minus 14x plus 49. B is 9b squared minus 12bc plus 4c squared. And c is a 4 minus 8a squared plus 16. The third thing we're going to look for is when we combine the two types of binomials, x plus 6 times x minus 6. Here, x times x is x squared. X times negative 6 is negative 6x, positive 6x, and negative 36. And when we combine our x's, we end up with 0. So our answer ends up being x squared minus 36. So we end up with a perfect square of the first one and a negative square of the second one when we multiply a plus and a minus. So let's try the shortcut here. We're going to find a square of the first one, which is x to the 4th, and a square of the second one, negative 4y squared. because there's a positive 2x squared y and a negative 2x squared y that will cancel each other out. This one is similar. We're going to go 49 is the perfect square for the first number, and then negative n squared for the second part. Okay? These are easy. Check it out number 3 on page 523 a try. Pause here, come back when you're done. Number 3, when we multiply x plus 8 times x minus 8, we get x squared minus 64. B, we get 9 and negative 4y to the fourth, and 81 minus r squared. And that takes us to the word problem. On the bottom of page 523, we have a koi pond, and the little fish are in the pond here, and there is a walkway around the edge. And we know that the length of the outer walkway is x plus 2, and that the width of the pool is x minus 2, and that these are both perfect squares. And what they want is just the area of the walkway. So we're going to take the area of the large square and the area of the small square and subtract the two. We're going to end up with the area of the large square, which is x plus 2 squared, which is x plus 2 times x plus 2. And that's going to give us x squared plus 4x plus 4. That's the large. Then we have the small, which is x minus 2 squared. And that's going to give us x squared minus 4x plus 4. And now we're going to subtract the two. X squared plus 4x plus 4 minus this whole thing, which means all of these become negative. Minus x squared plus 4x minus 4. So these cancel out, and these cancel out, and we end up with 8x as our answer. The area of the path is 8x. And then they go on to tell you, what if x equals 10? Then just looking at the answer here, we know that the area of the walkway is 80. If they asked us to go back through these steps, then the large length is 12, so 12 squared is 144, and the area of the length of the small square is x minus 2, which is 8, squared is 64, and if we took the area of the large square minus the area of the small square, we end up with 80. Your job is to check it out number 4 on page 524. There's going to be one like this on your test, so I'd like you to be good at it. Please try it now so I can walk you through it right after you push pause. So we have a swimming pool here, and the length of the swimming pool is 5 plus x, and the length of this part, the width, is 5 minus x, and then this area right here is a square that is x on both sides. So if I were to take the area of this rectangle, that would be 5 plus x times 5 minus x, which would be 25 minus x squared. And I would add to it this bit, this square, which is x times x, which is x squared. 25 minus x squared plus x squared is going to give me 25. Get to know your a plus b squared, your a minus b squared, and then your a plus b times a minus b, and make sure you can tell the difference. Your homework for this section starts on page 525. You're going to do numbers 22 to 60 even. Have a go at it. Let me know which ones you need help with, and I will see you tomorrow.